Hello, everyone. My name is Damilola Oladimeji, and I'll be presenting a paper we worked on this semester known as Identifying Depressive Tweets Using Natural Language Processing Frameworks. I worked on this paper with Laura Garland, Dr. Qingzhong. We are from Sam Houston State University in Huntsville, Texas. Okay, the overview or the content of what I'll be presenting today will include the introduction, what sentiment analysis means, our research goal, methodology, results, and conclusion. Okay, so depression is not a new terminology in this era that we live in. Depression is a mental illness that affects individuals of varying ages, and the number of patients being diagnosed with depression yearly is a growing concern amongst mental health advocates. In fact, the CDC reports that depression affects about 16 million individuals yearly, with 1 in 6 individuals suffering from depression at some point in their life. This means that you could be suffering from depression, or you know somebody else suffering from depression. Fortunately, with the rise in social media, we now have platforms that can help to, that can create data sets which can help for the early diagnosis of depression. With the diverse symptoms or the way depression shows itself in individuals is very different, and this makes it very difficult for us to detect depression in time. So with these different data sources, we can leverage machine learning to identify or diagnose patients suffering from depression, which could prevent things like suicide or depressed patients, the effect of depression affecting patients in their relationship with the family, school, or even workplaces. Okay, so we can use a feature in machine learning known as sentiment analysis for depression. Before we talk about sentiment analysis, we need to talk about natural language processing. Natural language processing allows computers to analyze text by combining language with artificial intelligence. So basically, it tokenizes the text or the message, and then gives meaning to it. We have examples such as ChatGPT, which is very common nowadays. We have text prediction, speech recognition, and sentiment analysis. So what is sentiment analysis exactly? Sentiment analysis is basically analyzing text to determine the meaning of the text of the message being conveyed, right? When we speak sentences or when we say things, we use different words, and these words all in their entirety mean something. It could be passing a positive message, a neutral message, or a negative message. So sentiment analysis works well with social media data, because in this, we see a lot of individuals putting out their feelings to the world, or the intentions, their emotions, through emojis and things like that. So sentiment analysis works very well with social media data. Okay, for the methodology, like the process we use to identify depressive tweets in this research, this is basically the entirety of the methodology we use. And as the presentation goes on, I'll go through each phase we use to determine our results. So the first thing we did here was the data set. Before you do anything with machine learning, you need to know what data you need, right? And for this, we got 2 data sets from Kaggle, one containing depressive tweets or sentences that convey depression from Twitter. And then we got another one with just random tweets, things that have nothing to do with depression. We then concatenated, we joined both of these data sets, labeled them, annotated them. So the ones for depression, we gave it the annotation 1, so that's its ground truth. And the one for random, we gave it 0. So the idea is that the input will be the text. So if, say, for example, a user gives a text, say, I am depressed, we annotate this with 1. If it's something random, like I woke up early today, we annotate it with label 0. And after all of the concatenation, we had a total of 14,000 rows for this particular research. Okay, so this is an example of what I was saying. For the text we labeled random, we have a text here saying, I like feeling this way. I like to be freelance. I looked like a needle. All these don't have anything to do with depression, so they're 0. And then for an example of the text in our depressive tweet or depressive data set is, I just told my parent about my depression, my anxiety and my depression, fighting over whose day it is, and different kind of things. Those things that signify that when an individual posts this on Twitter, you can tell this person is going through something at that particular point in their lives. Okay, so the next thing, now that we have our data set, the next thing we need to do is pre-process this data set and select the features that actually matter for training our machine learning models. And a common notion is the data you feed into your machine learning model is very important, because if you feed in a bad data, you're going to get bad results. So you want to pre-process your data so that your machine learning is working, your machine learning models or your NLP models are working with a really good data set for consequently giving you good results. Okay, so for feature selections, the random data set and the depressed data set that we combine, each individually had their additional columns. But for this research, we realized only the text column mattered to us. We only needed to know what messages were being put out there, or tweet data was being put out there by individuals from different regions of the world, right? So we just picked sentiment and the sentiment text, which consisted of text that we're going to use as input in models. And then we labeled those texts, which is the annotation to let us know if this is depressive, which earlier I said means 1, and if the other is random, which means 0, which we gave ground truth 0. So this basically our input sentiment text and the output label. So this is what we'll use to train our machine learning model to see its accuracy in detecting individuals that suffer from depression. So to pre-process our data, we did data cleaning and data randomization. Now, one thing that's very common, or one thing we realized from the data set we got, is that it included a lot of insignificant terms or terminology, such as usernames, website links, and punctuation, special characters. Those things don't really help in conveying the message. So we took those ones out. We also ensured to make all text lowercase so that all of the text going through the machine learning model is uniform. We removed no rows. Another thing we did is we noticed when a lot of people tweet, they don't really care about the typographical errors and things like that. So we tried to correct most of those the best that we could so that it gives the sentence more meaning to the machine learning model. We removed no rows so that every single row has data. And then we did data randomization. So with our data set being so large or being large, we wanted to ensure that we're reducing bias. So we use cluster sampling so that when the text is being fed into the machine learning model, it does it in clusters of different labels. It doesn't only pick ones or doesn't only pick zeros, because when it does that, it becomes very easy to predict if it just picks all ones in its first batch. So we did cluster randomization for this one. Cluster sampling, this technique will help reduce bias. So you know that your machine learning model isn't just guessing at some point. When it gets a lot of ones, it's like, oh, all of this is ones. So that's why we did that. Okay, now that we have our data set ready for training, we will start with the sentiment analysis, training it with a machine learning model to see if it can understand the meaning of the text being passed through this machine learning model is depressed or random. So we use 6 different NLP models or natural language learning models for our sentiment analysis. The reason is to have a comparative analysis to see which one of them has the highest accuracy, which would be best in creating techniques or software platforms that can be used for early detection. So the moment a user posts something, you can then signify or notify that this person is suffering from depression, and the person can be given. BERT is a bidirectional encoding representation from, it means bidirectional encoding representation from transformers. You can get the pre-trained model from Hugging Face. It was pre-trained with 12 layers, and bidirection means that it goes from left to right and right to left concurrently. It's a feed forward and self-attention max layer for tokenized word. I'm not going to go into too much details with all of this because they each have their own uniqueness to them. But I'm just going to give an overview of what these different NLP models do. XLNet is also a large language model. It introduces autoregression aspects to each training. So on top of that, it introduces autoregression. Regression means that it removes data corruption while retaining the benefits of bidirectional training. Roberta was created by Facebook, so it was like to improve BERT. So it stands for robustly optimized BERT. And what it does is it provides a higher possible number of training iteration and increase your text substantially to like get better results. The BERT, on the other hand, is known as a decoding enhanced BERT. It introduces disentangled attention and enhances the marks. So your attention marks that you give to it, it gives you a better accuracy. So the idea is just to kind of see if all of this actually makes your result better. Electra, on the other hand, removes maxing and introduces a concept known as token detection. Albert is just light BERT, where it, on top of BERT, what it does is it addresses issues such as long-time training, because when you're working with machine learning models, what you realize is you're training your data set for a really long time. You could be training one data set for 3-4 hours. So Albert kind of reduces that time by introducing two techniques known as two techniques to reduce parameter. One technique is known as factorized embedding parameterization, and the other is known as cross-layer sharing. So all of these have their individual advantages, and the idea of doing all of this is just to see if one or two or more creates more accuracy, which one can be used better, since BERT was the original and all of this kind of tried to improve what BERT currently does. To build and train the model, we used tokenizers, pre-trained model, learning rate. The epochs or the cycle time we use for this machine learning model, for this project, we use 4 in each of the models. We also gave it a max length of 140. The reason we chose 140 is because the greatest length of words you can pass when you're tweeting is 140. So you can't do more than 140 words when tweeting, when an individual wants to tweet at a particular time. The tokenizer we use for BERT, XLNet, Roberta, Albert, Electra, and Depressive, we have it there. What tokenizer means is you have sentences, right? When you're passing it to as input in your model, you need to break them into smaller text or smaller words that make sense to the machine learning model. So when you use this tokenizer, it passes it in chunks, like your one sentence, it passes it into smaller chunks into the pre-trained model. And then from this pre-trained model, it kind of gets the grand truth and to see, okay, from all of these chunks, once I put it together, does it make sense? Is it 1 or is it 0? And the learning rate is just 3E minus 1 is how you want your machine learning model to learn from your train and test data. So in this research, we split it into 80% test, 20% 80% train, 20% test. So that's how we did our splitting in this research. For our loss function, a loss function is how you calculate the error of your machine learning model. So based on the ground truth model, how do you get the performance of your machine learning model? In this research, we use the binary cost entropy loss function, being that we use only 1 and 0 for our output. So this loss function worked perfectly in this research. You can see the formula here. And from this loss function, we're able to get our accuracy, which is in the next slide, which is our result. After training our models, BERT performed at 99.95%, XLNet performed 99.89%, Roberta was 99.91%, Albert was 87.48%, Electra was 99.91%, and Deberta was 99.92%. From our result, we can see that almost all of them are in the high 99%, with BERT being the highest at 99.5% and Albert being 87.48%. This means that all of these machine learning models are able to identify depressive tweets at this particular accuracy. So they're really performing well. However, with Albert being in the 80th percentile, we wanted to visually see what was going on with the data set. So what was going on with the training. So we got the confusion matrix. Confusion matrix allows you to see the error rate. So visually see the performance of your model. From this table here, we can see the true positive. So the confusion matrix uses 4 terms: true positive, true negative, false positive, false negative, based on your predicted and true label. So what true positive means in this particular research is how many texts were classified as random and actually random based on the ground label, which is 0. So how many tests did it take as 0 and it actually represents random text? True negative means how many texts were depressed and it gave it the label 1. So it accurately identified 1. False positive means how many depressed tweets did it classify as random tweets? And false negative means how many random tweets did it classify as depressed tweets? So from here already, we know why, we were able to identify why Albert performed so low, because it classified 21 random tweets as depressed tweets. And then we can see why BERT had the highest accuracy with classifying only 2 depressed tweets as random and 1 as depressed. In general, they all did well in identifying tweets that were random, as well as identifying tweets that were depressed. So yeah. In conclusion, our research used 6 NLP model, or compared the performance of 6 NLP model in identifying individuals that are actually depressed. And our accuracy shows that we can actually truly leverage NLP models to identify individuals that are suffering from depression. So identify patients that are quickly suffering from depression, as well as provide solutions that could help them in overcoming this mental ailment. Future directions can be targeted towards optimizing pre-trained model to further increase accuracy rates among these frameworks, because it's still very detrimental to not be able to identify depressive tweets or to mix them up. You see depressive tweets and you say it's random. That could have really dire effect. We don't know what that person is going through at that moment. So we wanted to be able to identify each of these at, if possible, the perfect score, right? Yeah. So in acknowledgement, we want to thank the SHSU Institute of Homeland Security in this research. They helped provide our resources, and these are the references of any of the papers I spoke about or cited as I did my presentation. Thank you. This is my contact information if you have any more questions, if you want to reach out. And please, if you have any questions, let me know so I can help answer.